So this is our quiz. We'll go over it in class. Oops, let me close it. All right, perfect. Here's what we're doing. Oops. Oh, no. Oh, whoops, my bad. Try that again. Okay, so this is what we're doing today. We are going to go through the quiz. We're going to finish up notes 8A, and then we're going to get about halfway through 8B. Tonight you have Connect Math 7.3 due tonight. Tuesday you have 8.1, 8.4 due tonight. Next Thursday you have 8.3 due tonight, due then, and then on April 14th you'll have Lab Part 5 due. It looks like our exam is going to be April 21st. And then we'll do a day or so of review and then have our other exam, our makeup exam from 3, 5, and 6. We'll have that probably on the 28th most likely. Okay, and again, you don't need to have a white background and all that other stuff. You guys will figure that out. All right, make sure you fill out the office hours survey. I'm going to start an office hours based upon that survey. I'll start those tomorrow, next week. And then if you want to pick up handouts on my doorstep, remember that I'm in the complex, so you have to go up my street and then turn right into my complex, and I'm in the building on the left. So it's not on the street, it's on the kind of on the inside. All right, so let's go over a couple things that people were I want to make sure people are really clear on, since we've got a lot of things going on, a whole bunch of new things. The first one is, if you have a bad internet connection, if things are choppy when you come in, or not, you're skipping things, or you're not hearing it at all, then use your phone audio option when you sign in. Surprisingly, it makes a really big difference. It takes up a lot of bandwidth for some reason, the audio. I don't know why, but it takes up a lot more than you think it would. So when you sign in with your phone instead, it just takes a lot of the weight off of it, and everything runs a lot smoother. So when you sign in for audio, choose the connect via phone and call one of the phone numbers it shows, type in the meeting number and pound, and then type in your user number, which shows up on the screen, and then pound. And then the audio will go through your phone, but you can still control it through the mute and unmute on your computer screen. It's very cool, super useful. That's what I do. Where's everything in Canvas? Adam, do you want to go and read this one for us? Yeah, I'll have you read the next one. I'll do this one. So the announcements is where all the important information is. So if you go there, everything that's important I'm posting in there. Assignments, that's where you upload your quiz and your notes and things like that. So assignments, if you hit assignments over here, you'll get this. So this is where you upload everything. If you haven't uploaded it, make sure you upload it, because this is how I count your credit. So for this one, you're supposed to upload the 7.1 quiz and also pages 4 and 7 from your Chapter 7 notes. For tonight, you're going to upload your 8.1 quiz and also page 14 from the 8B notes. So just upload those 2 pages so that I know, that you have been doing your work and everything. So that's how you get your participation points, which is 15% of your grade. So that 15%, 4 points is just for being here, and then 6 points is for uploading. So then if you aren't here for all of it, then at least you can get those points. And then the last thing is the stuff about our pages. So if you go to the home, the top module is the links to the class Zoom and other stuff, and then handouts are in the second group, which includes the notes and quizzes and the T-table, and then the PowerPoints and videos on the next one. So I'll show you what I'm talking about. This first one, links to Zoom lectures and office hours, are right here, because I'm going to Zoom my office hours as well. Here's another resource page for online learning stuff. And then the next one is handouts. So these are our notes and quizzes for these 3 chapters, for those 3 chapters. And then if you need a T-table, download it here. And then everything I do in this class, I'm videotaping these. So all the links to the videos are going to be in here. And then also PowerPoints, if you want the PowerPoints, they're here. And then the board PDFs, everything I write and physically write out will be saved as a PDF and put into these here. So this is for our chapters 7, 8, 9 would be down there. And then these are other things, the project and study guide and other stuff. Okay. Next, we're going to take a look at, so now, Adam, why don't you go ahead and read this? That'd be great.
All right, can you hear me?
Yes. Go ahead.
Okay, what about the handouts? Quizzes can be done on plain paper. Don't write the problem, just number solution. If you're able to write on a PDF via tablet, you can absolutely do that, even more under the March 31st announcement. If you would like to pick up handout, you can do that either in Pleasanton, the announcement from the law, or TC, email me your address, and I can drop them this weekend. Other than the areas, I can mail them. Email me.
Good. Perfect. So yeah, I can definitely get you guys, the handouts are super useful. So it's just best if you guys have all the handouts for the rest of the semester. So just email me if you need to get those, and we can figure out how to get them to you. Can I take this class? Can I drop this class or take it PNP? Absolutely. So we just met yesterday and talked about this. You can do what's called an XW, so it's an extreme withdrawal just for COVID-19. You can do that anytime now until the final, which is our final, I think, is May 19th, I think. You just have to fill out a form. If you go to announcements, the last announcement, it's on there. I'll link to that. And then also, you can also take a class, pass, not pass. Any class at LPC this semester, you can take pass, not pass. However, make sure that wherever you're transferring to, that they accept it. The CSUs and ECs will accept it for this semester as long as it is not a class in your major. So in other words, if you're a geology major, you cannot take a geology class pass, not pass. But you could take this class pass, not pass. You know, but if you're taking if you're biology major, then you really need to take the biology classes for a grade. The other classes you can take, you know, pass, not pass. That's no problem. All right.
Professor?
Yes.
We get that option for the pass, no pass option right now or at the end of the semester once we get our final grades?
I think you have to do it before the final. I think. I will get more information about that. But I believe my notes said you can do that anytime during the semester, I think. But that would mean before the final. Yeah. But you should have a good sense before the final how well you think you're, you know, whether you think you're going to get a C or, you know, an A or a B. So hopefully that will.
And a pass, no pass, like a pass would be like C minus, would be like
C minus. So you need 70% or better to pass this class. Absolutely.
70% or better, right?
Yep. Hey, Austin, while I've got you here, why don't you go ahead and read this one?
Okay. What if I haven't done an assignment? Still do them. I am being pretty flexible on getting in your quiz slash notes. If you are more than a week late, I will take off some points, but not all. For tonight's math homework, I am changing the late to 20%, starting with tonight's homework.
Great. So yeah, so still do them. I mean, a lot more lenient because people have got things going on. You know, still please get those in. All right, so we're going to take a look at Chapter 8, Hypothesis Tests. So again, reminder, a hypothesis test, it's a test to see if your sample is unusual or not. That's the whole point. Is your sample unusual or is it pretty typical? If it's usual in here, then that's kind of normal and nothing exciting happens. If you get something unusual, that's when you write a paper, right? I mean, you get stuff out here in these unusual areas. I remember that the null hypothesis says that my mean, your mean, is the same as everybody else's mean. So for example, you know, I have a pill. I have a magic pill that will help you get higher grades, test better. So if you take my pill, I'm saying the mean of the people who take, the average of people who take my pill is going to be higher than the general people. The null hypothesis says that I'm the same. So it's saying that here's the regular mean for everybody, and the null hypothesis says that my mean of people who take my pill is the same as everybody else. It's right here. So if my sample falls in this kind of usual range, then I can't dispute that. I have to say, okay, fine, maybe my pill doesn't do anything. Maybe they are the same. But if I get something in this unusual range over here, then I could say, look, my pill makes a difference. I can reject null hypothesis. The null hypothesis says mine is the same. I can reject that and say, no, mine's not the same. Mine does something. Mine's different. So I've got something unusual, and because it's unusual, then I can claim that my pill really does work, that it really does make a difference And it's not people who take my pill, their average score is not the same as everybody else. So that's kind of the point of a hypothesis test. Very often, hypothesis tests, you want to get an unusual result. Often, not always, but often. All right, the null hypothesis, why am I reading? Soraya, please read.
The null hypothesis, symbolized by H0, is a statistical hypothesis that states that there is no difference between two parameters, mu equals mu naught. The alternative hypothesis, denoted by H1 or HA, is stating that the parameter has a value that somehow differs from the null hypothesis. The symbolic form of the alternative hypothesis must use one of these symbols, less, greater, and equal.
Exactly. So again, the null hypothesis, null meaning none, zero, no, right, means no difference. Null, no difference. If there's no difference, then they're equal. Two things are equal. So the null hypothesis is always equals, always. Because null means no difference. No difference, equal. The alternative hypothesis has to differ. How do you differ from equal? You have to be something else that's besides equal. You could be greater than, less than, or not equal to. But it has to be one of those. Because the null hypothesis always equals, alternative has to be something else. So here is your first quiz. And we're going to kind of read through this. Let's see. My claim is, this is my claim, the mean weight, in other words, the mu, equals 105. Mu equals 105. That's your symbolic. It's pretty, hopefully pretty clear on that one. So here my claim is that mu equals 105. Now, we know that H0 is always equals. Okay, you guys pay attention, this is important. This 105 doesn't change. The 105 is the same for all of these. H0, H1, the claim. What changes is this symbol. Equals, not equals, less than, greater than. That's what's going to change. H0 is always equals, so it's going to be that something equals 105. Mu equals 105. Mu equals 105. So now the question is, are these two the same? Mu equals 105, mu equals 105. Yeah, they're totally the same. So since H0 is my claim, then H1 has to become the opposite of whatever H0 is. So that this only happens when my claim is H0. Then H1 becomes the opposite of H1 becomes the opposite of H0. So this would become mu is not equal to 105. Let me see if I can draw this correctly. That was kind of good, not horrible, not great. There we go, that's better. Okay, so mu is not equal to 105. Is this one-tailed or two-tailed, guys? What do you think? One or two-tailed? Anyone? Two-tailed, exactly. Two-tailed. Perfect. Good. Then we're going to take a look at the next one. Here, believes, that's his claim. Once you say believes, that's the same thing as claiming. Believes his oxygen levels. This data is numerical. So numerical, it's going to be a mean. So his mean is going to be higher than 65. His mu is higher than 65. So how do I write that? Mu is higher than, greater than, yeah, exactly. Greater than 65. Perfect. Thank you. And again, H0 is always equals. So it's going to be that mu is equal to 65. This number doesn't change. 65 never changes. Just it's the symbols that change. So mu is equal to 65. That's my H0. Always equals. Are these two the same? Nope. This one's greater than, that's equal to. Remember that the number has to stay the same. It's the symbol that may change. So since these symbols are different, that's greater than, that's equal. They're not the same. So if they're not the same, that means the H1 has to become whatever my claim is. My claim has to be one of those two. So if H0 isn't my claim, I have to make H1 my claim. So here I'm going to put H1 is mu is greater than 65, done. Good? Is this a one-tailed, two-tailed test, guys? Which one is it? One-tailed. Good, nice job. Perfect. So you'll notice, and this is interesting, that really almost always, most of the time, my claim will be H1. Because my claim is going to be H1, and whenever my claim is greater than, less than, or not equal to. And very often that is what we're trying to prove. The only time that our claim is H0 is when we have this situation. When our claim is. When our claim is, that's when mu is equal to 105. We put mu equals as our claim, and that's when H0 is our claim. And then H1 becomes not equal to. That's the only time that really we have this situation is when our claim is, then H1 becomes our claim, and H1 becomes just the opposite of whether this is. Otherwise, H1 will always be whatever our claim is. Whenever our claim is something other than equals, then H1 is always going to be our claim. Any questions on that before we move on?
No.
Okay, good deal. All right, so then here is our test stat. And the test stat is just the z-score of your sample, your sample's z-score. So how do you find the z-score of it? So we know before from chapter 6, this is how we found it for using central limit theorem before, x bar minus mu over sigma over square root of n, right? Because this becomes our new standard deviation whenever we have a sample, and we're using a sample mean. That standard deviation becomes smaller because we're taking a big sample, and they're going to kind of cancel each other out a lot, right? So Steph Curry's 50-point game will cancel out his 10-point game, and you're going to get something a lot closer to the average. So we do this sigma over square root of n. But remember that for these tests, it's very unusual that we don't know sigma. We don't know mu, but we know sigma. So pretty much we're going to use this one instead for our means. So this is what we'll use for our means. So it's very similar, x bar minus mu over s over square root of n. Whenever we have a mean, we use that. And whenever we have a proportion, we'll use this one. Our sample proportion, p hat, what we got from our sample, minus what we expect to get from our claim, divided by square root of pq over n. And that pq is from our claim because that's what we expect it to be. So we'll take a look at yours and see what you guys, oh wait, let's do an example first, sorry, my bad. So from last class we did this little XSort sample example, if you guys remember. We sampled 100 couples and we found that 58 of them were girls. XSort claimed that they would have a higher likelihood of girls than usual. And the usual, what's typical, what's usual is you have 50% girls. So this is what our H0 is, a null hypothesis. It says that XSort is the same as everybody else. Everybody gives 50% girls, so XSort will be like everybody else, it'll give 50% girls. The XSort is saying, hey, wait a second, we can increase your likelihood of girls, so our proportion is going to be higher than 50%. So their claim is that their proportion is more than 50%, increases the likelihood of girls. So what we do is we take our p hat, our sample proportion, based upon our sample was 58 out of 100, so that's 0.58. And we're going to subtract what we expected to get if there was no difference, which was 0.5, and to divide that by square root of pq over n. So here we have it. We've got our p hat, what we got from our sample, minus what we expected to get from our claim, 0.5, divided by square root of pq over n. And again, we're assuming that p is correct. We're assuming it's 0.5, so that's why we use 0.5 here. To get this. And what we found was we got a z-score of 1.6, which seems like maybe it makes a difference, but not enough to be unusual, because our guideline for unusual is 5% typically, which is usually closer to a 2 standard deviation. So this is, well, it seems like maybe it does change it, but it's not enough to really prove for sure, conclusively, that it does change it. So your problem was this one here. So here's the claim. The claim is, so first write down your claim. It makes life easier. Claim is the proportion is 0.25. So there, right there is my claim. Claim. P is 0.25. Good. Now, remember, your claim, this is really important. People get messed up on this all the time. Your claim is your P, right? This is P. This is what I'm claiming. So that's the P, right? It says P equals, that's my P. The P hat, that's from the sample. So P hat, right, let me type this out. P hat is from sample. So P hat's going to be, let's find the sample, the word sample. Sample includes 540 P's with 128 of them being yellow. That means that my P hat is going to be the sample, 128 over 540. So if you're not sure, people screw these up all the time and they mix these up. Find the word sample, or if you can't find the word sample, it might be disguised as surveyed or selected. But that's your P hat. That's what you get from the sample. The P you get from your claim. Find the claim, that's your P. So here we're going to have our test stat. Test stat is the same thing as your, oh, I can use my finger, I think. Test stat is going to be the same as our z-score. So how do you find a z-score? P hat minus P over square root of P Q over N. So this is going to be, oh, this was 0.237. And give me 3 sig figs here, guys. 0.237, give me 3 sig figs. Minus 0.25 over square root of 0.25. If my P is 0.25, then my Q is going to be 0.75. I just have to add up to 1. And how many people did I sample? 540 people. And I think you guys ended up getting 0.698, I believe. Right? I believe that's correct, 0.698. Yes, okay, good. 0.698. Perfect.
Professor, I have a question.
Yeah, totally.
So P hat is equal to 0.237. So I thought Q would be the remainder of.
Ah, right. And I understand what you're saying, and that's common. Oops, that's common too. The thing about it is that our H naught is that P is 0.25. And remember, we assume that H naught is true. We're assuming that our proportion really is 0.25. Our sample was 0.237, but we have to assume that we always have to assume that our H naught is true. So to assume that P is 0.25, which is why we're going to use 0.25 and 0.75 here. But you're right, that is a little bit confusing, and that's the reason why, is because we're assuming, we have to assume that this is true, that P is equal to 0.25 until we hear otherwise. So we have to use 0.25 for these numbers, and then see if this ends up being unusual. So we're going to see if this is unusual based upon the fact that we think that this is the true number. So that's the whole idea, is if this is true, so in other words, if this goes into all these numbers here, then is this unusual? So yeah, good question. And I understand that that can be really confusing, because I got confused on it when I first learned it as well. Because, you know, you're right, instinctively you might think it would be one thing, but it really is because we're assuming that this is true, we've got to use this all along the way.
Okay.
Yeah, great question. Thank you for asking that. That's super, super great. We did those ones. Yeah. Another question?
My just negative.
Oh, I'm so sorry. It is negative. That is totally right. I'm completely wrong. This is negative. Thank you, thank you, thank you. Negative 0.698. Good. Thank you for fixing me. Okay, cool. This was kind of where we left off last time. We did not get to this. Angelo, can you read for us? Angela A?
Oh, sorry about that. My microphone was muted.
No worries.
A type 1 error occurs if one rejects the null hypothesis when it is true. A type 2 error occurs if one does not reject the null hypothesis when it is false.
Perfect. Great. So again, if you think back to when I was mean and played that trick on you guys with my deck, we were assuming, the null hypothesis, that my deck was, you all assumed that my deck was a regular deck. So the null hypothesis would say that the proportion, my proportion of red cards should be 0.5. But we got something super unusual. So what you guys did was you said, Biz Young, we had 6 red cards in a row. There is no way that this is true. The null hypothesis is true. We're going to reject the null hypothesis and say that you fixed the deck. Right? We're going to reject the null hypothesis because we think that this is not true. Your proportion of red cards is much bigger than 50%. Now, so that could be correct if my proportion really is not 50%. But it's possible that my deck could have been 50%, and if it was, and you rejected null hypothesis, then you're making a type 1 error, which is that sometimes, randomly, you will just get something unusual. And you'll think that it's unusual. You'll think that it's unusual because your mean is different when it's really not. So here's an example. The proportion of, in Baccarat, you can either be player or banker, and the proportion of them is roughly 50-50. So my second time playing Baccarat, I went out there and I bet $25 on banker. It came player. I bet another $25 on banker. It came player. So then I bet $50 to get my money back. It came player. So I bet $100 on banker to get my money back. It came player again. I bet $200. It came player. And I only had $375 left, so I bet all that on banker. It came player again. So it came player 6 times in a row. Very unlikely. Does that mean that the probability was not 0.5? No, I would have rejected the null hypothesis and said, oh, probability of banker can't be 0.5. It must be something smaller, and that would have been wrong. Because the probability really is 0.5. I just got really unlucky, right? And I happened to get one of those unusual cases where, where I happened to get six players in a row. So it can happen, and it will happen like roughly 5% of the time, right? If we're saying 5% is unusual, then that means 5% of the time you're going to get something unusual. So that would be a type 1 error when you reject H0 when you really shouldn't, when you just had something unusual. And then if you don't reject H0, most of the time it's going to be the correct decision, because most of the time you don't reject H0 and your sample really isn't that unusual. But, say we drew it and we had 2 out of 6 people got black cards. We'd say, okay, that's possible, that's reasonable, we will not reject H0. But maybe I only had 2 black cards in the whole deck, and those happened to get drawn, and all the rest of the deck is red, and just was lucky that someone happened to pick that. So that could happen also, where what you got in your sample didn't accurately reflect what you actually have. Or it might be like this thing right here as well. This is another good example where we have this XSort method, right? And we ended up with a z-score of 1.6. If you look at 1.6, that's a pretty decent Z-score, right? I mean, if I kind of put it into the table, it's kind of out here, right? So that's kind of unusual, but we kind of say, oh, it's got to be 5% or less. It's got to have a Z-score right around 2, typically, right, to be unusual. And this is close to 2, but it's not 2. So maybe XSORT really does give you more girls than usual, but just we want the evidence to be higher. We want it to be, maybe there's an 8% chance or a 10% chance of getting this, and we want a 5% chance. So, we've set the bar a little bit higher, and it just can't, we don't have enough evidence to prove it. But maybe it does give 58% girls all the time, and if we took a sample of 1,000, maybe it would be good. Then we still have a big enough sample or strong enough evidence. So that also happens. So that's a type 2 error. Is if you really if you don't reject the null hypothesis, but you really should. It really does make a difference. It really is different, but you just don't have enough evidence to prove that. Let me just further demonstrate that type 1 error. Remember, we did this from, I don't know, some previous chapter. We took a bunch of samples, right? These are all just different samples, and most of them are pretty close to the real mean. But maybe you got this sample way out here, and you didn't realize that it's an unusual sample. You've got an unusual sample. And you said, oh, I got something way over here. This can't be my mean, and you reject the null hypothesis, when really you shouldn't. It's just that you had an unusual sample without realizing it. So that's that type 2 error, when you unknowingly have a strange sample, so you reject the null hypothesis when you should not reject the null hypothesis, right? Because you happen to randomly get one of those 5% of times you got something unusual. That's called the alpha. So alpha is the significance level. It's the level of unusualness. So typically for us, what's our level of unusualness? We consider something unusual if it is, help me out guys, 5% or less?
5%.
Thank you.
5% or less.
Thank you guys, awesome. 5% or less. So typically our significance level is 5%, right? 5% or less is usually what we consider it, so that our alpha is typically 0.05, usually. However, it could be other numbers. We'll talk about that in a minute. So that means that the probability of getting a type 1 error is 5%, right? Because 5% of the time we're going to get something unusual. That we've set that level and said, here's all the possibilities of things that can happen. The outer 5% of them, those are going to be unusual. And if you get something in that range, then you're going to be rejecting the H0 when you shouldn't. That's the type 1 error. If you guys remember back how 84% of published papers are false, it's because thousands of people did all these experiments, and 95% of them got nothing unusual and did not write a paper. 5% of the people happened to randomly get an unusual sample without knowing it, and they wrote a paper because they're like, oh, look, I got something unusual. This is great. And they write a paper, but you can't reproduce it because it wasn't that what they're stating was really true. It's just that they had an unusual sample. And then likewise, the probability of type 2 error is beta, which kind of matches up with, as your alpha changes. Here's my alpha. Alpha is this part here. So the smaller my alpha, the more likely I'm not going to, smaller my alpha, the less likely I make one of these errors. But the more likely I make one of these errors because I have my guideline for passing the test for being unusual becomes harder and harder. So, maybe normally my test would be right here, my sample would be here, and I'd say, oh, it's not unusual. You have to be over here to be unusual. So I wouldn't reject H0 when I really should. It's a matter of not having enough proof. I don't have enough evidence. So it's sort of the level of evidence you set for it. Typical significance levels, we talked about those earlier. Usually it's 0.05, sometimes it's 0.10 or 0.101. So these are all the typical ones that are used. You know, and so, you know, for example, when alpha is 0.10, that means there's a 10% chance of getting an unusual sample. So reject the null hypothesis when you shouldn't. This is the same alpha we had in chapter 7. It doesn't change, hasn't changed at all. So why don't you guys, I know I haven't really covered that type 2 super well. I kind of touched on it. Well, I don't want to spend a lot of time on this, but I do want you guys to do this problem 5 on your worksheet. It's the very back of your notes, of your 8A notes. So go ahead and work on that in your groups, and